So this video is really going to be focused on using reinforcement learning to help us out with trading. Now, I've mentioned GME, but this could just as easily be used with different stocks, Forex, a whole bunch of different equities and other types of securities as well. So in terms of what we're going to be covering, we're going to be using the OpenAI Gym AnyTrading environment. So this is a custom trading environment that you can use to trade a whole bunch of different types of securities. What we're then going to do is we're going to build a custom training bot using reinforcement learning, and specifically we're going to do that using the Stable Baselines package, which is just a really great package to get started with reinforcement learning really quickly. Then what we're going to do is load in GME trading data into our trading environment. So hopefully our reinforcement learning agent is able to learn how to trade that particular stock. Let's take a look as to how this is all going to fit together. So first up, as I said, we're going to be using the AnyTrading OpenAI Gym environment. So this just makes it easier to build a custom trading environment. We'll then load in our GME price data that we've got from MarketWatch, and this will be available in the GitHub description below, as will all the code. And then we're going to train a reinforcement learning bot to try to trade against that particular environment, ideally trying to make additional profit on top of our portfolio. Ready to do it? Let's get to it. Alrighty, so in order to get started with reinforcement learning for trading, there's going to be 5 key things that we need to do. So first up, what we need to do is install and import our dependencies, and really we're going to be relying on the Gym AnyTrading environment there, as well as Stable Baselines. Then we're going to want to bring in some MarketWatch GME data, so specifically GameStop data. And again, in this case, we're going to be using daily data, but if you could get minute data or even second data, that's probably going to give you a much more sophisticated model. Ideally, the data that you use should mimic the frequency that you want to be trading at. So once we've done that, we're then going to build up our environment, and this is specifically going to give us a trading environment that allows us to work with OpenAI Gym. Now, in this case, the environment that we're going to be using is called Gym AnyTrading, and it allows you to pass through a whole bunch of different types of data. So say, for example, you didn't want to do it on GME, you wanted to do it on AMC, or if you wanted to do it on Bitcoin or Ethereum or a different cryptocurrency, you could actually do that simply by passing through different reference data to our AnyTrading environment, which is actually pretty cool. Once we've got our environment built, we're then going to train our reinforcement learning model, and specifically for that, we're going to be using Stable Baselines. So this is a great reinforcement learning package, which I've recently discovered, that allows you to do a whole bunch of sophisticated stuff reasonably easily, and then we're going to test it out. So we'll train on, for example, 50 to 100 days of data, and then we'll test it out on the next 10 days. Now again, all the code here is shown for demonstration only, so if you are going to deploy this, please do your own research, and it's not meant to be financial advice. Alrighty, first things first, let's go on ahead and install and import our dependencies. Alrighty, before we go on ahead and run that, let's take a look at the line that we've written. So in order to install stuff from within our Jupyter Notebook, we're just going to pass through an exclamation mark, then pip install, and then followed by all the different packages that we want to install. So the first one that we want to install is TensorFlow-GPU, and specifically we want to install version 1.15 because Stable Baselines only works with TensorFlow versions below version 2 as at this point in time. So we're going to be leveraging those versions of TensorFlow. So TensorFlow-GPU equals 1.15.0 will allow us to do that. Then we've got TensorFlow equals 1.15.0. So this is also giving us the non-GPU version of TensorFlow to make sure that we've got both bases covered. Then the next dependency that we're installing is Stable-Baseline. So this is going to give us our different reinforcement learning algorithms. Then Gym AnyTrading. So this is going to give us our trading environment. And then last but not least, we're installing Gym as well. So this is going to give us OpenAI Gym, which is the base framework that Gym AnyTrading is actually built on. So the entire line is exclamation mark pip install TensorFlow-GPU equals 1.15.0, TensorFlow equals 1.15.0, Stable-Baselines, Gym AnyTrading, and Gym. So if you go on ahead and run that, that's going to install all of your dependencies that you're going to need to be able to get this up and started. And you can see it's already installed, and this has gone reasonably quickly because I've already got a large number of these dependencies installed. Now the next thing that we want to do is actually go on ahead and import our dependencies. So there's quite a few here, so let's go on ahead, write them out, and then we'll take a step back and take a look at them. Alrighty, so those are our dependencies now imported. So we've gone and written 7 lines there. So if you add in the comments, that's 10 lines. So we've broken this up into 3 different sections. So first up, all the OpenAI Gym stuff. So first up, we've written import Gym, and this is going to be the same dependency that we installed up here. And this is really OpenAI Gym. So it gives us our base framework for reinforcement learning and building reinforcement learning environments. Then we've imported gym-anytrading or gym_anytrading, and this is going to give us our specific trading environment. So to do that, we've written import gym_anytrading. So these 2 environment components are actually where our trading bot and specifically our trading reinforcement learning model are actually going to learn to trade. Then we've imported some dependencies from stable baselines, and this is really where we get all of our RL stuff. So any of our reinforcement learning algorithms and specifically our helpers, like our dummy vec environment, are imported from stable baselines. So we've imported 2 dependencies there. So from stable_baselines.common.vec_env import dummy vec_env. So this is a vectorized wrapper that basically we wrap our trading environment in order to pass it to stable baseline. So think of this as a wrapper. Then we've imported the actual algorithm that we're going to be using. So in this case, it's A2C. So to do that, we've written from stable_baselines import A2C. Now you could try out a whole bunch of other different reinforcement learning algorithms. So if you actually take a look in stable baselines, there's actually a whole bunch that you can try out here. So there's ASA, PPO2, SAC, the all famous DQN. So there's a bunch that you can actually try out for this. Then the next set of, so that's really our reinforcement learning stuff imported. So really our dummy vec_env and our algorithm. Then we've brought in some processing libraries. So we've brought in NumPy. So import NumPy as NP. So we're going to use this a little bit later on when we go to evaluate our model. Import pandas as PD. So we've brought in pandas to be able to read in our GME trading data. And you'll see that when we actually go to step 1. And then last but not least, we've brought in matplotlib. So this is going to give us some visualization functions when we go to plot out our trades that we've actually gone and passed through. And that is really our dependencies imported. It's really our gym environments, our stable baseline algorithm stuff, and our processing libraries. Those 3 components, or those 3 sets of components, are going to be the core dependencies that we're going to need for this. So that's really step 0 now done. Install and import our dependencies. Now we're up to step 1. So bringing in our MarketWatch GME data. And in order to do this, we're really going to be relying on pandas here. So again, if you wanted to, you could actually change this data. So I actually had a Bitcoin data set that I got in from Kaggle, but I've also got a GME data set. Given how prominent it is at the moment, I figured it might be useful to take a look at that as well. Now again, this is for demonstration purposes. So if you were going to go try this out, please be mindful that this isn't financial advice. It is really to show what's possible with the technology. For deep reinforcement learning, trading bots trained with over 10 years of market data, get membership at deeptradingbots.com. Bitcoin data set as well. It just will require a little bit of additional pre-processing. So you can see here that I've got a data set called GME data, and it's in a CSV format. So we're going to be leveraging that. So let's jump back into our notebook. So we're now going to bring it in. So in order to bring this in, we're actually going to be using pandas. So let's go on ahead and do that and take a look at what our data set looks like. Okay, so that's our data now brought in. So in order to bring it in, we've just used the pretty much standard pandas read CSV functionality. So we've written df equals pd.read_CSV, and then we pass through the path to our data set. So in this case, it's going to be data/GME data.csv. If you had data sitting in a different folder, you just need to specify the full path to that particular data set. If we wanted to bring in our Bitcoin data, for example, I could just type in Bitcoin data, and that would bring that in instead of our GME data. But in this case, we're going to stick with our GME data, and we're going to take a look at that. So if we type in df.head, this is going to show us what types of data we've actually got in there. So we've got date, open, high, low, close, and the volume as well. Now again, this is just a straight download from MarketWatch. So I selected a custom range, which you can see over here. And then basically all I did is I hit download data. And this allows you to download a data set from MarketWatch. But again, if you had more rich data sets or a data set with a increased level of granularity, you might choose to use that as well. And also, if you want to see how to build custom indicators and how to use different indicators, please let me know in the description below. I'd be more than happy to take a look at building a video on that. So in this case, we're going to stick with our pretty straightforward data set and start setting this up for trading. So in order to actually do that, what we need to do is first up convert our date column to a date time type. So if I actually take a look at our D types at the moment, you can see that our date is just an object. Now, in order to get this to work with the Gym AnyTrading environment, we actually need our date to be a date time. So we can do that reasonably easy using the pandas.toDateTime function. So let's go on ahead and perform that conversion first up. All right, so that's our conversion now done. So in order to do that, we've written 2 lines, and really we only need to write the 1 line. The second line is to do the display. So we've written df, and then we'll pass through an index, which is date, and this is basically resetting or overriding our date column with our new datetime function. So to convert the date column, we've used our pd.toDateTime function. So in order to do that, we've written pd.toDateTime, and then we've passed through our date column. So this is effectively taking our existing date column, passing it to our pd.toDateTime function, which then converts it to a datetime type. We then go and overwrite the existing date column with that new datetime type. And then if we type in df.dtypes, you can see that we have in fact now converted this to a datetime 64 type. So this is going to now be able to work with the Gym AnyTrading environment. But in order to pass it through to that, we need to make one more change. And specifically, we need to set this column as the index. So this is just the way the Gym AnyTrading environment expects to receive the data. So let's go on ahead and do that first up. Alrighty, so that's our column now set as an index. So in order to do that, we've written df.setIndex, and then we've specified the column that we want to have as our index. So now we can actually refer to this by date. So to do that, we're in df.setIndex. We've passed through the date column as being the column that we want as our index. And then in order to do it in place, we've just set in place equals true. So this means that we don't need to go and make a copy of our data frame. We're just updating our present data frame in place. And then we've gone and shown the 5 top columns, so df.head, and this just shows us our first 5 columns within our data set. But again, the core changes that we've made is we've brought in our data set, we've converted this column to a datetime type, and then we've gone and set it as our index. And that's really all you need to do in order to be able to get started in terms of passing this to our AnyTrading environment. Another thing to note is that it does expect to have certain columns. I believe it needs open, high, low, close, and volume. But again, I'll clarify that in the comments below just so you've got an idea of what types of data it's actually expecting. But that's really it in terms of the different types of data transformations that you need to perform to load up a custom data set into our AnyTrading environment. But again, a key thing to note that you could sub this out with a bunch of different types of data if you wanted to. Okay, so now what we're going to do is we're actually going to pass this into our AnyTrading environment that we had up here. So let's go on ahead and do that. All right, so that's our environment now created. Now again, think of our environment as where our reinforcement learning bot or our reinforcement learning agent is going to learn how to trade. So if we actually take a look at our environment, you can see that we've got prices, I believe. So this is actually taking all of the prices from our data frame and displaying it out there. We can also take a look at the different signal features that it's going to use as part of our trading. And I believe it takes price and the change in price from the previous time step. So it's actually doing a bit of a difference, which is why this first feature here doesn't actually have a difference because it doesn't have any previous data. So in order to create this environment, which you'll see in action in a second, we've gone and written one key line. So we've written in env equals gym.make, and this is from our OpenAI Gym that we brought in up here. And then because we've imported and installed Gym AnyTrading, we're able to set up a template environment. In this case, we've set up the stocks environment. So to do that, we've written stocks-v0. Then the next parameter that we've passed through is the data that we actually want to work on, which in this case is our GME stock data that we just went and pre-processed. So to set that, we've set df equals to df, so a keyword argument, and then we've gone and set two other keyword arguments that you can play around with. So the first one is we've set what portion of data that we actually want to be included within our environment. So in this case, we're including the first 100 time steps, and we're starting from the 10th time step. And I'll explain this, why this is actually needed. So we actually need this to be at minimum number 5. And so the reason that we need it to be a minimum of number 5 is because when we set our window size, we need this first parameter equal at least this or greater. So what actually happens when you set this window size parameter is you're actually specifying how many previous time steps our trading bot is going to have as reference data for when it goes and makes its next trade. So in this case, we're specifying our window size equals to 5. So this means when our trading bot is trying to determine whether or not to place a trade, it's actually got the 5 previous sets of price and price difference. So effectively, these 5 sets of signal data or 5 sets of signal features are what our trading bot is going to have access to. So in this case, you actually need to start at 5 so that it's got 5 sets of previous data. And then this second parameter, you can change and tune that to whatever really that you want it to be. In this case, we could set it to 100, we could set it to 150, but you can't obviously go more than the maximum amount of data that you've got. So if I summarize that entire line, we've specified env equals gym.make. We've specified that we want the stocks environment, so stocks-v0. We've passed through our data, which in this case is our GME data, by specifying df equals df. Specified how much data we want to pass through to our environment by setting frame_bound equals 5,100. So we're going to start at the 5th time step and go all the way to the 100th time step. And then we've specified how big we want our window to be. So in this case, it's window_size equals 5. But again, you could pass through more data, you could pass through less data as well. And then you can take a look at the environment by specifying env.prices. So in this case, if we type in prices, we can get our prices. We can also take a look at our signal features. And I think it'd be really cool to extend this out and actually build some custom signal features. So say, for example, we actually went and calculated some specific financial formulas. It might be interesting to bring those in. But again, let me know in the comments below if you'd like to see a video on how to do that. So for now, we've actually got our environment set up. Now, the next thing that you're probably wondering is, okay, that's great. How do I actually see this live and in action? Well, let's go on ahead and test out our environment. So rather than actually trading properly, we're just going to take a bunch of random actions and see how this actually performs. And if you watched any of my other reinforcement learning videos, so this is akin to creating a test environment. And really what we're trying to do here is establish how it actually works and take a look at some of the features available within. So let's go on ahead and do that, and we'll take a look. Alrighty, so that's our environment tested. Now we've written quite a fair bit there, and specifically we've written 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of code. And basically what we've actually gone and done is 2 things. So we've gone and run through a bunch of random steps within our trading environment, and then we've actually gone and visualized it out. So we can actually break these 2 components out separately. So this entire code block here is really similar to what we've written. If you've ever watched any of my reinforcement learning tutorials before, pretty much the exact same as what you might do in any other OpenAI environment. In this case, we're just testing it out. And specifically, we're just taking a bunch of random steps using env.actionspace.sample. So if we take a look at the whole bit of code, so we've written state equals env.reset, and this basically allows us to get our initial state. And ideally what we're going to get back out of this is our signal features from our environment, and specifically our 5 windows, or the 5 components within our window. Then we're basically looping through each step, and we're taking a random action. So within most OpenAI Gym environments, you're able to access the action space. So if we actually take a look at that, so env.actionspace, you've really got 2 different actions that you can take within the any trading environment: buy and sell. So they don't actually have a hold environment. I believe it's only buy and sell. And if you actually scroll inside of here, you can actually take a look. that it really only has long and short positions. I don't believe it's got a hold position really. Yep, so it's only got sell and buy, which you can see down here, which are these two actions that you can see here. Now, in order to access those actions, we can actually access our action space, so env.actionspace.sample, and this is just going to take a random action. So it's akin to just randomly buying and selling GME shares. And then we're actually going to take that action and store it inside of a variable called action. And then we're going to apply that action to our environment, which you can see here. So basically we're calling env.step and we're passing through our buy or sell action to our trading environment. Then out of that, we're going to get our state again. So we're going to get what our environment looks like, our reward, so whether or not we made any profit, whether or not we're done. And ideally our done is going to trigger once we've gone through all of the different steps within our trading environment. So really the different time or the different days that we've got within that data. In this case, remember, we're using 100 minus 5 data, so 95 days worth of data for this particular environment. Now, if we're done, then we're going to print out our info and break the loop. So you can see the info has been printed here. In this case, we've got our total reward of 64, which doesn't mean too much, but we're specifically interested in this total profit figure. So we've actually managed to lose money. So our total profit is 0.78%. So this is our profit plus our balance. So if we actually made a profit, we'd expect it to be 1 dot something. In this case, taking a bunch of random steps has actually lost us money, which is pretty much as you'd expect to happen. So everything up to about this line, or everything that you can see visualized in this line, is really this code here. So it's just taking random actions. Then the cool thing about the any trading environment is that you can actually visualize the environment as well itself. And in order to do this, we can actually use matplotlib. So remember, we imported this over here in this line. So in this case, what we're doing is we're calling, or we're resizing our plot and setting it up. So plot.figure, fig size equals 15,6, so 15 by 6. We're calling plot.cla, and then this is the most important function. So env.renderAll allows us to render all of the different trades that are happening or that have happened as part of our trading within that particular environment. So you can see the red dots are shorts, the green dots are going long. In this case here, you can see that it's trying to short up here. It's shorting here, which is probably an absolute terrible trade. Shorting up here, which isn't so bad. Buying down here or going long, maybe not so good as well. And then we're calling plot.show. So this actually renders the plot. So all up, you can see that we've taken a bunch of random steps within our environment using these two lines, and we're effectively visualizing it out. But you can see now, you can sort of get an idea of how we can actually play around with this environment. Now, this is pretty much step number 2, building our environment now done. So we've created a test environment and we've tried it out. Now it's actually time to actually start building our reinforcement learning model to try to actually trade profitably in this particular environment. Now, again, you can sub out different types of data. If you wanted to, you can get more granular or high level. I believe this data is daily. So if you actually take a look, yep, so it looks like day. So 11th of March, 12th of March, 10th of March, 9th of March, 8th of March, so on. So what we're now going to do is build up our proper environment and actually start training it using stable baselines. So first up, what we actually need to do is wrap our environment inside of our dummy vectorized environment wrapper that we brought in up here. So we're going to create our environment, wrap it in this, and then we're going to create an algorithm using the A2C algorithm and start training it. So let's go on ahead and kick off that first bit of code, which is where we need to wrap our environment inside of dummy vec environment. So let's do it. Okay, so that's our dummy vectorized environment now created. So in order to do that, we've written 2 lines of code. So env_maker equals lambda, and then we've included a colon, and then we specified gym.make, pretty much this exact same line that we had up here. So when we actually created our dummy environment. So we've specified, so gym.make stocks-v0. Another cool thing to point out is there's a generic environment. There's also a Forex environment as well. So if you wanted to do something more like commodities trading, you might choose to use that. It actually has different, I believe, bid and ask spreads as well as different fees applied. So then again, in this particular line, we've again specified we want to pass through our GME data. So to do that, we've written df equals df. specified our frame bound. So in this case, we're going to be using 95 days worth of window data again. And then we specified our window size equals 5 again. So this entire component here is exactly the same as what we wrote just above. The only difference is that we've now appended a Lambda function to the front of it. So this is basically going to allow us to loop through and create multiple environments if we wanted to. In this case, we're just going to be using the one environment. So when we're calling dummy vec env, we're passing through a square array and we're passing through our env maker variable, which is what we had here. And we're storing that inside of env. So if I summarize, we're creating an environment maker function. We're then taking that environment maker and we're putting it inside of our dummy vec env wrapper. And we're storing that inside of a variable called env. So basically, when we now go and start building our training model, we're actually going to be using this env variable here. And that brings us to our next step. So we're now up to actually setting up our algorithm and actually kicking off our training. So let's go ahead, write that code. And before we start running it, I'm going to tell you what to look for and actually how to train this. So let's go ahead and do it. Alrighty, so those are our next 2 lines of code done and dusted. And really in these 2 lines of code, we're going to start training our reinforcement learning bot to start being able to learn how to trade GME. So in order to do that, we've written model equals A2C, and A2C is the actual algorithm that we're going to be using inside of this particular run. So again, you can try using some of the other algorithms that we've got here. So ASA is one that's quite popular. So is PPO2. And again, if you wanted to use your own custom algorithm, you could do that as well. So we've written model equals A2C, and then we've passed through the policy that we want to use. In this case, we're using a multi-layer perceptron LSTM policy. What this basically means is we're going to be using a deep neural network, which is why we need a TensorFlow right at the start, which has a LSTM layer. And this is really, really important when it comes to trading, because our LSTM layer allows our neural network to keep context and learn about previous history within its neurons. So it's actually able to take into account what's happened in the previous windows to work out what the next best trade outcome is. Then the next parameter that we've passed through is our environment, which we had up here. And then we're specifying verbose equals 1. So passing through verbose equals 1 just allows us to get a bunch of information as our model is training. Then the next, so this particular line here is really giving us our algorithm. So this is our algorithm now set up. Now the next line that we've set up is really where we start to train our algorithm. So we've got model.learn, and then to that we've passed through total underscore time steps equals 100,000. So if you've watched the video on training reinforcement learning models with stable baselines, again, these will be pretty familiar because effectively we're just using an algorithm and then we're just going on and kicking off and learning. I'll link to that video somewhere up above. Check it out. So now what we're going to do is we're actually going to kick this off. So ideally what you want to be paying attention to as you start training is you want to take a look at the explained variance value. So you want this to be as high as possible, because that means that your model has begun to learn about all the different variances within that particular data set and is now starting to understand some of the patterns. So what we're going to do is we're going to kick this off, and if we get to a point at where it's significantly high, so ideally you're going to be looking for a number between 0 and 1, the closer to 1, the better. So if we get to a high level, we'll stop that model and then we'll give it a test. So let's go on ahead and test this out and take a look at how this is going to run. Actually, before that as well, you can actually configure something called a callback within this learning function as well, which allows you to automatically stop the model when it hits a certain level of accuracy as well. So if you'd like to see a video on that, by all means, mention it in the comments below and I'll take a look. In this case, let's go on ahead and kick it off. So you can see our model started training, and you can start to see these explained variants, the FPS, the number of updates, our policy entropy, how many time steps it's taken, as well as our value loss. So ideally, you want your explained variance to be as high as possible. So ideally, the closer to the number 1 you get, the better. And you want your value loss to be as low as possible as well. So if we keep scrolling down, ideally you can see it's sort of bumping around, and this is pretty common. But if you start to see a value which is close to 1, then ideally you might want to stop it there and test it out. But again, there's a more structured way to do this. If you want to see how to do that, by all means, drop a mention in the comments below. So we're going to wait and see if we get to the elusive 0.99 explained variance, and then we'll stop there and we'll see how our model is actually trading. Alrighty, so we managed to stop our model training with an explained variance of 0.129. We had a value loss of 0.0669 and a policy entropy of 0.204. Again, if you'd like a deeper description into this, again, hit me up in the comments below. I'm more than happy to explain this in greater detail. But ideally what you want is as high a possible explained variance as possible. This is going to give you a better model. You can see that as we were getting towards the end of the training, so if I scroll a little bit further down, we did have an explained variance of 0.903, so only a couple of steps before. So ideally this should give us a model which performs reasonably well. But again, with all things algorithmic trading and reinforcement learning, finding the perfect solution isn't always super straightforward. So in this case, we managed to get a reasonably well performing model. So again, we had 0.903 up here and it bounced to the negatives and then hung around still in the positives before we managed to stop it training. So now what we want to do is actually test this out and see how it actually performs. So we're going to test it out over 10 days and see how it actually performs trading in that particular space. So let's go on ahead and write this out. This is going to be really similar to what we've written up here. So we might even reuse some of this code, or we'll probably write it from scratch and see how we go. So let's go on ahead and do it. So we're going to take this model and we're going to test it out and see how well it actually performs. Alrighty, so that's our evaluation code now written. Now, before we go ahead and test this, let's take a look at the code that we've written. So first up, what we're doing is we're creating a new environment and we're passing through again stocks, our data frame, our frame. Now, in this case, we've specified that we want to go from day 90 to day 110. So there is a little bit of overlap with the trading environment or the training environment that we actually had. So again, the more data that you've got and the more significant your trading factors are, the better this is likely to perform. So again, having that overlap is cheating in some senses. But again, this is really just for demonstration, just to show you what's possible really with reinforcement learning. And then the last thing that we've passed through to that environment is we've set our window size equal to 5. So really similar to what we had up here, but we're not wrapping it inside of this dummy vec env. Then we're specifying really similar code to what we had inside of our test environment here. The core change, however, is that rather than taking random actions, we're now actually using our model and predicting which action it should take. So whether or not it should buy, sell, or hold. So in order to do that, we've written OBS equals OBS. So this is taking our observation, and we're basically just reshaping it using numpy.newAxis to be able to work with a non-vectorized environment. We're then passing through that observation to the model.predict function. So this is effectively taking what our current environment looks like, passing it to our predict function and generating a prediction. Out of that, we're getting the action that we should take as well as our states. So this action is really one of the most important components because we're then going to apply that action, so buy or sell, to our trading environment to take a look at how that's going to perform. So this should not have an equals. And then we're going to get back from that our rewards, whether or not we're done, and any info. So this info is going to tell us what our profit looks like at a point in time. So all things holding equal, this should run and we should see how our trading environment performs. And again, we'll test this in a few different scenarios just so we can see what it looks like. So in this case, again, we've got the overlap. We'll test it without overlap so we can take a look at how the reinforcement learning bot is actually performing. Okay, so let's take a look at what we've done there. Oh, we need to have obs here. Alrighty, so that's our reinforcement learning model operating on day 90 to 110. And it looks like our total profit in this case is about 3%. If I zoom in on that, you can see that we've got a multiple of 1. So we've got 1.03. So this ideally is about 3.1% return. But again, this has our overlap. So we might not actually be performing that well in the real world. So if we take away the overlap now and say if we went from day 110 to day 140, oh, it looks like our profit drops to about 60%. So now we're losing cash. So if we went earlier, for example, say we went completely within the trading cycle. So what would that be? Day 70 to day 90, again, 58%. So it looks like 90 to 110, it was trading pretty well. But again, outside of that, maybe not so well. So that was 5%. So again, 5.5%. So again, you can play around with this. We can visualize this again to take a look at what it looks like. So let's go on ahead and grab our viz code, which we wrote just over here. And so you can see it looks like it's short selling here, which probably wasn't the best trade, short selling there, buying long, so it's not doing too bad there, shorting again, buying. So again, looks like it's shorted correctly there. So again, you can play around with this, see how it actually performs. You might choose to create some new signals, you might choose to add additional data, train for longer, and ideally there's a whole bunch of stuff that you can go and perform to try to get this training better. But this at least gives you a broad overview of how you might go about using reinforcement learning and artificial intelligence to start trading. So who knows, maybe you might refine this and be able to get a top of the shelf trading bot to be able to go on ahead and make the most out of GME and a whole bunch of other different types of stocks. So if we wrap up quickly, what we've gone and done is we've installed and imported our different dependencies. So remember, we had our gym dependencies, stable baselines, and our processing libraries. We then brought in our MarketWatch data, and specifically in this case we use GME data, but if you wanted to, you could use a bunch of different types of data, Bitcoin, Ethereum, crypto, different commodities. You could try them all out here reasonably quickly. For deep reinforcement learning, trading bots trained with over 10 years of market data, get membership at deeptradingbots.com.